Okay, so for this next video, we're going to go through what a sample spreadsheet may look like for doing data analysis using Stata, and the spreadsheet should look quite familiar to something you might see in Microsoft Excel. And the data that I'm pulling here are from a combination of sources. So I actually created this spreadsheet for this class, and we have data that are from countyhealthrankings.org, and they provide, data on a variety of things. And ultimately, they use the data that they collect to rank the health of each county by state and by the United States. So you could explore the health data. You can use the data. There's different. They update this site periodically, so there's different ways of getting to the data. But you can actually download the data, or if you're interested in a particular, county in the United States or in Kentucky, you can look up, something like, how does Owsley County, Kentucky compare to the rest of Kentucky? And their health status is not very good, 118 out of 120. You can also compare against, you know, other counties on a county by county basis. You can sort it and use the spreadsheet to compare for the whole country, or you can just download all their data, by actually, following some steps on their website and actually downloading the data. Also, what I used was this, IHME website. They provide life expectancy data. You can download it, and I was able to pull the two data sources together and sync them up and double check that I was able to bring them in by FIPS code. So these data are right now viewed as red, so that means that the software is treating them as nominal or categorical or ordinal type data. Doesn't know how to deal with them. It can't deal with them as a continuous data set on these things that are red. It could have been when I brought in this FIPS code one, the way it was entered, it could have been text or something. So when we see red text in Stata, that means that it's viewing it as, or when you see red, it's viewing it as like text type data. It's viewing it like nominal or categorical, ordinal or something like that. Now you can have ordinal data that may show up in black as well, but that means that it can also be used in a continuous fashion by the software. So in the case of FIPS code, that is the federal identification number that is assigned for each county, and it allows us to grab data from a variety of sources and then link them all by FIPS code, because in some cases there are some counties in the United States like Fayette County, where there's a lot of Fayette counties in the United States. So if you've got multiple Fayette counties and you're linking by that variable or by that county name, you're going to have a problem with a lot of duplication, whereas there's only one FIPS code that is 1001 in the United States, and that's for Alabama and Autauga County. So when I pulled the data from the big county health, health rankings database, so the County Health Facts website from University of Wisconsin's Population Health Institute, they get a grant from Wisconsin or they get a grant from the Robert Wood Johnson Foundation to make that website possible, and it's a real helpful tool for teaching, and also for communities and people to know a lot about their own health and their county's health compared to the country. So just some of the data that are available, they have more in there. They have the percent of the population that has physical disabilities. Now, this name has been shortened in the STAT program. So Stata, unlike Excel, does not allow you to put an infinite number of characters in this, so it will truncate it or shorten it if you import this data or copy and paste in variable names that are too long for this. So it'll truncate it at so many letters. I'm not for sure on all of the variable names that I brought in, but this is the percent that are diabetic. We have the HIV prevalence. I don't know if that's per 100,000 or per million or per 10,000 or what. Probably per 100,000. They have the percentage of the population facing food insecurity, percentage with limited food availability, number of drug overdoses. I don't know if that's per, so you'd have to know your units before you want to use your data, but they have all kinds of stuff in here. So here's a median household income, annual medical costs per family. So this is all ecologic data. It's all organized at the county level or correlational type data. We also have data in here as it relates to percent Pacific Islander, percent Hispanic, and so forth. So all these data are in here in a way that they can be treated in a way that you could kind of work with them, or the software will let you work with them like they're continuous data on these. On these, it's not going to let you work with it like it's continuous data. So that's just a little view of what the what the software looks like. Here I actually coded the FIPS code in a way that it's actually numerical, and then I imported data from that other website for life expectancy, and then I've got the FIPS code for it, so you can see that they match. You can also do a scatter plot on FIPS. So I have to know the names of those variables, and I had like FIPS new, and the other variable name was FIPS 3. So you'd want to know that those are the same. They should fit perfectly. You should be able to regress them, and they should fit perfectly, whenever you're importing data. Should be a 100% match. So the R square is 100%, so 100% of FIPS new is explained by FIPS 3. This is our Y, this is our X, so it works perfect. So that's that's what we would expect from perfectly matched data. So that's just a little background into what the actual what the actual spreadsheet kind of looks like. Now you can go into it in more detail on your own and play around with it, but again, the red, this stuff is stuff that we can't use the software very easily to do. Now there are some things that we can do here in the future on coding data. We might be interested in coding people. Whenever we got continuous data, it's usually optimal or ideal, but you might be interested in breaking these groups down into certain, in the large counties versus small counties based on population, or you might want to code it into, lightly rural, somewhat rural, highly rural, totally rural, or no rural. So you can categorize it and make continuous data, or data that appear to be at least semi-continuous, and make it into categorical data. So all those things are possible. Now we might periodically be dealing with data that come from individuals. When we deal with data that come from individuals, it'll look pretty similar, but instead of the units of observation here being counties, the unit of observations may be ID, or patient ID, or person ID, and it might be 1, 2, 3, 4, 5, 6, 7, 8, and 100, 200, and so forth. We probably don't want to see people's names in this type of analysis. So that kind of concludes this little intro to what the data set might look like when you put it into Stata. So just a little intro on the back end of it, and we'll move on into the next set of material here shortly. Thank you.